Welcome! In this video, we will amend the two programs created in the last few videos to store our dataset in the server application and query that dataset using the client application. Both applications will be compiled using the PowerBasic Console Compiler. Communication between the two applications, hosted on two separate computers on the same network, will be by the User Datagram Protocol, UDP. We are going to use code from the two previous videos. Generate data, which took in a few source files and created some random data in a consoles application that displayed progress on a graphics window, and the UDP server, which listened for requests coming in via UDP and responded. We will merge the code from these two programs to provide an application that will generate a random dataset and allow it to be queried across the network by an application on another computer. So, this is the program which we used in the previous video to generate our data. We're going to merge that in with the code we had for our UDP server. Now, the mechanism I'm going to be using to do that is to take most of the logic out of the UDP server code and put it into a library, which we're going to call UDP routines. This is going to perform several key pieces of functionality. It's going to allow us to open up a UDP channel. It's going to allow us to listen for requests, and should we receive a request, it will then process that request, and then on command it will close down the UDP channel and terminate the application. So, how are we going to call that within our generate data program? Well, in here we have the logic we had before for the common libraries for file handling routines, generating the version for the application, and linking in the random routines as an SLL, static linked library. I have now added to it the include file, which I've created for UDP routines, which pulls the key functionality for UDP out of the UDP server application. And in here, we're doing as we did before, we're generating the data file, we're putting progress out to the graphics window, which has been created up at the top of the application here, and down here we're going to put in the bit which will sit and listen for requests. It will do this by calling an openUDP function to open up the UDP channel. It will then push a message out to the graphics window to say it's listening for the broadcasts. It will then listen, and then once we exit out of the listening routine, it will then close down UDP channel and it will terminate the application. So if we have a look at the functions we're actually calling for openUDP in the UDP routines, in here we set the name of the machine. In this case I'm running this on the Octal computer. We're clearing anything out the error function. We are doing exactly as we did before in the previous one. We're picking up the IP address of the machine we're currently running on. We're creating a file handle. We're opening a port on the UDP channel with a timeout of 1 minute, 60 seconds. If we're going to have any error, we're going to put something out to the console. Now, we don't necessarily need a console in this application, but for the purposes of actually seeing what it's actually doing under the hood, I've let the console go. Assuming that the connection has been established, we're putting a message out to the console to say UDP open, and we're finishing the function. So, that will open up the UDP channel. The setting of the progressive text we covered in previous videos, that just updates the graphics window, and then we're listening for requests. If we have a look at the listen for request function, quite a straightforward one, puts a message out to say it's listening to the console, blanks out any incoming request. This is a variable we use to store the incoming request. It will then run the process requests, and if it got a request for the command exit, it will then exit out of the application and close down UDP channel. Otherwise it will just sit in this loop indefinitely. And inside this loop we're calling the process request, and the process request function is the one that does all the work. This is the one which is listening for an incoming message on the UDP channel. If the first part of the message matches the server name we're actually running on, then it will send a message back. If the name does not match, and if the name does match, then we'll get down to the part where we actually process it. Now this is exactly as it was in the previous video. I'm just showing this to demonstrate we're actually using all these routines as a library inside the Generate Data application. Now, in order to query this server type application via UDP, we've created a UDP client application, which is just the same as the one we had previously. All this one does is it sets the name of the machine it's going to connect to, it does a number of calls to the UDP server. Now we're going to comment out the one which exited because we want the server application to run continually at the moment. And down here, this is where we actually query the UDP server. Again, this code has not changed since the last video. So let's try running it. Let's run our Generate Data application first. And there we go. It's running in the graphics window to generate the application, and it's got the data in 6 seconds, and it's now sitting waiting for broadcasts through the UDP channel. And here's our console window. We'll just make this a little smaller so we can see it, which is currently sitting waiting on requests coming in. Now if we create a bit of space on screen so we can see what we're doing, and we go to the client application and we run our client application, there we go, there's a client application running, and our client application quite happily says that the list command was accepted, the TV command was not accepted. So there we have our connection. And on the server side, we got 2 messages coming in from this IP address, one for list and one for TV. And as we saw, the process was to pass a message back saying accepted and pass another message back for Octo TVs to say not accepted. Now this is the kernel of the application which we're about to build. What we want to do now is we want to pass message to the server application to say that we wish to query the data that's actually inside that array. So how would we do it? If we have a look at our client application at the moment, we're calling this query result. So we're going to create a new call, and we want to actually get some data back. So let's create a command called count, and we'll take these other commands out at the moment. Now if we run that now, if we terminate our application and run the client now it's going to pass not accepted because the server doesn't know what to do with the count command, which is fine. What we're going to do is we're going to change the application on the server so that it does perform some functionality with the count command. So if we go back to our server, if we terminate the application on that one, and we go back to our server code. Now, in here, where we had the actual commands in the UDP routines, this is where we actually performed each of the functions. Now, we're going to create a new one called count. Now what we want to send back here in this case is the how many records are there. Now we know that when we brought the data in to generate data, we put the data into an array, and this is the array here. It's a global array, so we can reference it inside the library quite happily. this is array holding the data set. So if we go back to here, and what we want to do is we want to do UDP send back to the machine which it came from, back to the port, now we know the name of the array is ASTR work, so we'll copy that, and since we want to return the number of records, what we'll do is we'll do a U-bound. Right, since this string is quite long, we'll just fold it around to the next line so we can see what we're doing. So what that would do is when we send the command count, it should send back a string saying records equal, and it should have the number of records. So if we save that, go back to our generate data, run our program, let it run quite happily. There we go, the server process is now sitting waiting, and if we go into the client, and if we now run the client, there we go. We sent the command count and we got back from it records equal 1000. So there is our client sending a request to the server for specific information, and the server passing back the information we're actually after, which is excellent. So if we terminate our server application, go back to our client, we could do lots of interesting information requests in here. So we could create another one, and let's put in a query of something specific in the data. So if we're looking for, let's look at our data first of all. What's our data actually got in it that we could query quite happily? Now, this is our data set where we have the different fields. We've got first name, surname, address, telephone, eye colour, blood group. Let's say we're interested in eye colour. That's a good one to do. So, let's do something along these lines. So we're doing it a little more complicated. We want to sum how many people have actually got a particular eye colour equal to, let's say, blue. So this query is now going to ask a specific question which we want our backend to actually return. So what we've got in here is that string there, that entire string there is going to come in here, and it's going to be an str request. So str request is going to contain something like that. Now, what we want to do is we want to parse this out. So we will make a change to str request using our parse command which we've used before. And we want to parse it by spaces, and we'll take the first one. So what that will do is it will take just this as being the information that's in SPR request, and we've still got buffer. Now that means count will still function. So we're looking for sum, and how we're going to handle this one is we're going to put it in auto function, keep it away from the main code. We'll call it function sum. Now we're going to give it a parameter. Now we know the request equals that, so we know it's going to be a sum. So what we want is we will have whatever's in the buffer, which will be the whole string. So we'll pass that to there. So if we're creating a new function, we'll come down here and we'll put function in. We're going to return, it's pretty academic what we return in this one. What we could do, we'll return a string, yes. And what we will do is we will create this command to return the value when it gets something back. And what we will return back is that as a string. So the data we send back is going to be the output from the function. That'll make it nice and tidy. So all we have to do now is to work out what the value is. So we'll create a local variable. And this is going to be a string. So what we get in is going to say this. We want to chop this up. We want to parse this. So what the buffer is going to be equal to when it comes in is basically that. So this first parsing is going to trim out the octal. So all we're going to be left with is this. So after that, our string is going to look like this. Now we know this particular function is only going to handle the sum command, so we want to trim out on the first 4 characters. And what you can do now, you can use one of the other string commands we haven't used yet called $. $$ will take the middle of a string starting at a particular character position, and we know that 2, 3, 4, we want to start at 5, so we'll start at str request, we'll start at position 5. Now normally in a $$ you would say I want to start at the 5th character for X number of characters, 4, 5, 6 characters. If you omit that optional parameter, it will take everything until it gets to the end of the string, which is good because this is now going to contain this. str request is going to be equal to that, which is ideal. What we're after down now is we want to pick up the column. So the column we want to be equal to the words iColor. So how do we actually get that? Now, since we have delimited this by single quote, we can use our parse command again on the str request variable, and we're parsing it on single quote, and the iColor is the second delimiter. That would be the first, that would be the second, that would be the third, that would be the fourth. So we're after the second. So the column is going to be the second. Now we're only passing it an equals, so we could actually pick out the type of thing we want to actually do. So we'll just call that type. We're not going to be using this, but it'll be useful for later. So we can do type equals, and again it's the parse command again. And this will be the third one. And in this case, the value we're after is going to be the fourth one. Which would pick out the word blue. So having got all the values we've got now, the first thing we have to do is we have to work out which column we're actually dealing with. Now we perform this particular function earlier in a previous video. So we're just going to steal the code we used for that. Now, in our file handling routines library, we have a function which was designed to pick out the column number of a specified column. So we're just going to reuse that. Now, this parse find function actually looked at a string called str headers for a delimiter, and then you gave it the column name and it pulled out which column that was actually in, which is exactly what we're after. Now the column name in this case is iColor, which we saw from our source file. So that's the column name we're actually looking for. So we can just basically paste that in, put it in quotes. The delimiter we're looking for in this case was tab delimited, I believe. Yes, it was a tab. So we'll put the tab reserved word in, and the str headers are going to be the top line of our array. So we can put that in quite happily, which is a str work, the 0 element. So all we have to do now is we'll define our long up here, which is going to contain the column number. So by this point we will have determined which column we're actually looking for. So now we'll have to loop through the whole array to find out how many actually have a match for this iColor. So we will need a little variable to allow us to loop down through the array. So we'll do a standard for next loop for the first element to the upper bounding of the array, and then we do next. Now we're looking for matches, so we need to count how many we actually find, so we'll need a counting variable. Now, long count would normally be initialized as 0. We'll put that in explicitly just to be on the safe side. And we'll put an if command in. We want to actually test. So we're parsing out the data which is in our array for the element we're looking at, which is handled by long R. We know it's a tab delimited string, and the one we're looking for is the one pointed at by long column. So if we actually find it to be equal to whatever it is we're looking for, now we know the value we're looking for is going to be this variable. So if it does actually find a match, then we can basically up the value of long count. Now, as we saw from our performance video, the most efficient way of actually doing that, short of going down to assembler, is just to use the increment command to add 1 to the long count. Now by the time we get to the end of this, then this value is going to contain how many people there are with blue eyes. So we're returning this as a string, so we want to return something along the lines of this one here. So we want to return maybe records equal and then format of long count. Now that should, assuming we have made no syntactical errors in our code, actually be quite happy. So first thing we'll try is we'll try compiling our program to see if we have made any syntactical errors, and of course naturally we have. I didn't put in in function. Okay, let's try that. And it seems happy. That's good, just one error. Right, so if we try this, let's see what we get. We'll run our server program first, which will basically seed our data, which is what it's doing quite nicely. and it's now listening. So we'll then go back and we will run our client application. Now our client application, as we set it up to do, is going to quite happily use count first, which should return 1000 as expect, and it's then going to try this sum eye color equals blue. So assuming we've got all our code correct and we haven't made any errors, when this runs, it thinks the program's already running. Why does it think the program's already running? Is the program already running? Ah, yes, the program is indeed already running. So let's close the previous program and let's try running this program now to see what we get. Well, it has actually taken the command. However, the value it's passed back is 0. So something has gone wrong with our logic. So we've missed something in our query code. So let's have a look and double check on our UDP routines. Now in our function, which was doing the summing, we're passing it a string, which is the buffer we've got in from the client application, which has the name of the server, the function we want to perform, the column I'm interested in, and the value in that column I'm interested in. Now, okay, the first thing we're doing in the request is we're forcing that whole string to uppercase, which is not very good because it's going to force the column name to uppercase. So we don't really need the uppercasing, so let's take that out. So the str request is now going to be matching quite happily with that, which is the value we had in our my data string, the large data file. If we look at that, yes, it was indeed mixed case eye color. So that's fine. Oh, now the other thing that I noticed we're going is all the names of the eye colors are not uppercase. So since this is a case dependent test, down here, yes, we're actually checking to see if it's that. So we want to make it case independent. So we'll force them both sets of strings to be lowercase. You could force them to be uppercase as well. It could be done either way, and that way it will be a case independent comparison because they'll both be in the same case. That'll do nicely. The other thing which we may want to do is we've hard-coded in the column we're looking for is eye color, and basically we're picking up that column here. So we will replace that hard coding with what we have in the string. So that should match. Right, is that everything? That would appear to be everything. Okay, let's give that one a whirl. Let's run our server. What have we done? We got an extra bracket in here somewhere. 1, 2, 3, 1, 2, 3. We have got an extra bracket. Let's try compiling that now. Yep, that one's fine. Okay, now we've got our syntax correct. We can try running our server application, which is not showing the console window, although we've commented one too many things out. Let's just double check. Oh, we commented that out. Right, let's try running our server now and we'll see what we get. So there's our array being built up, and we're now listening for broadcasts. So we'll make this window a little bit smaller, give us a bit of breathing space, and we will attempt to run our client application. And there we go, we have actually got some data coming back. So we have queried the system to ask how many entries we have in the array, and it's come back with 1,000. We've also queried it to say we want to sum the number of people with the eye colour equal to blue, and it has returned 163. So it's quite correctly gone into the array, swept through it, looked for any entry with the eye colour equal to blue, and returned 163. Now in theory we can do that with any of the columns, so just to prove that that will actually work, let's go back to our client and we'll put in another query, and we'll try a different column just to show that our sum thing will work properly. We're going to look for blood group, so if we copy that and we put in blood group, we're still going to be using the sum function, and we're looking for people with this as a blood group. So, will that work out the box? Now our server code is still actually functionally running, so we don't have to do anything with that, we just have to run our client code now. So if we run our client code, there we go, it has successfully run. It has queried the count, 1,000, it's queried the eye colour, got 163, and it's queried the blood group and got 123. So this is an excellent demonstration of how we can actually have the code in a server application with all the data, which can be on a completely separate machine. We can run the query from a client application, querying specific information, and the server will then return the values to the client. Now, this has been a fairly simple approach, but it has built upon all the videos we've done previously, building up the data set. So, thank you for watching.